Hello students, welcome to EPG Pathshala. I am Monica Seni from Department of Anthropology, University of Delhi. Today I am going to discuss on the module Study of Fragmentary or Burnt Bones for Establishing Identity under the Forensic Anthropology paper. After studying this module, you will understand different categories for establishing identity. You'll be able to differentiate between male and female skeletons. You will also be able to understand age at death and how the positive identity is established. Establishing of identity can be done by taking into consideration four basic dimensions of the body, namely sex of the person, age at death, height, and ethnic identity. These four dimensions are approximated either in isolation or collectively, which provides a preliminary picture to be established in order to have a probable identification of the deceased individual. Sex determination can be better manifested from the distinct recordable differences existing within the skeleton of both female and males. The more distinct are the sexual differences, the more accurate would be the assignment of sex from the skeletal remains. In the prepubertal phase, sexual dimorphism is slight, hence, sexual determination during the juvenile stage is difficult than in adult stage. The areas of high sexual dimorphism in adult are the skull and the pelvis. The complete identification of the deceased would be rather difficult if the skeleton is incomplete and fragmented. Thus, it is necessary that the remains should be clearly or carefully retrieved by the recovery personnel or the forensic anthropologist. In case where commingled remains or fragmented remains left from the explosion are found, the preliminary step is to reconstruct the body of the individual for assignation of skeletal remains. Moreover, it is extremely important to identify and assign a body to its correct site and in the correct position within a skeletal sequence. Now I'll be talking about the determination of sex in adults. The foremost step of biological identification is sex determination, as the approximation of age and stature are sex dependent. For determination of the sex to be reliable and well grounded, it is based primarily upon whether the remains are complete and the level of sexual dimorphism inherent in the population to which the individual belongs. The male and female skeleton can be differentiated on the basis of two morphological differences. The male bones are generally larger and heavier due to the attachment of larger and more powerful muscle mass, larger size of the body, and a period of delayed pubertal growth as compared to the female bones. Secondly, the male pelvis is primarily adapted to a bipedal striding gait. In contrast, the size and shape differences of the female reflect the biochemical compromise between efficient walking and modifications necessary for the passage of large fetal head through the pelvis canal. Now you will be studying the difference between male and female skull. In regards to the shape of pelvis, the male pelvis is high and narrow, whereas the female pelvis is wide and shallow, with a comparatively larger inlet and outlet dimensions. Another characteristic which leads to the differentiation is the shape of greater sciatic notch, which is wide, shallow, and big in comparison to the ala of sacrum compared to the width of its body in case of the females. Thus, the most visible differentiation reflected posteriorly lies in the shape of greater sciatic notch, relative proportion of the body, ala of the sacrum, and anteriorly in the subpubic angle and shape of the pubic bone. In case of skull differentiation, the skull bones become more informative and visible at the time of puberty, where the skull of males are seen to have more muscle attachment, whereas the skull of females tends to retain their more pedomorphic features. In case of males, features like glabella, supraorbital ridges, mastoid process, and the knuckle and the malar areas becomes more prominent as compared to the females, where all these features are smaller and the forehead remains vertical with more pronounced frontal and parietal eminences. As regards the orbits, in female they are more rounded, have sharper margins, and are larger relative to the upper facial skeleton. The mandible of males have a more prominent chin region, a more robust lower border, a greater body height, and a more prominent muscle markings. The angle formed between the body and the ramus is more acute in the males than in the female. Sex differences show the relatively larger muscle development of the male in rest of the postcranial skeleton, especially in relation to the overall joint size. Now, I will tell you the age estimation at the time of death in juvenile and young adult stage. Chronological age estimation from the skeleton is based upon the measures of growth and development. Growth is referred to as the increase in the size. The increase is accompanied by a change in form or function, which is development. Maturity is the attainment of adult form and function. The initial phase is primarily under the control of genetic and environmental factors, which includes children and young adults who undergo changes that proceed in a relatively undocumented pattern at a moderately predictable rate. The changes related with age in an adult skeleton are quite prominent and significant once maturity is reached. These changes are more individual and population specific, especially at the stage when maturity has reached and proceeds towards senescence and subsequent degeneration. First, I'll be taking the age estimation in juveniles. In the fetal and juvenile period, age estimation depends primarily on the appearance and fusion of the major center of ossification and on the size of various skeletal elements, which includes growth and development. The dental age may be obtained from the time when eruption or mineralization begins, and they are said to be much closer to the chronological age than the skeletal age. Dental age indicators have thus long been regarded as the gold standard, as being less impacted by various influences such as sex, nutrition, and ill health than bone growth and development. The skeletal age can be approximated from the size and as well as the length of long bones of the body and from the development state of center of ossification that has occurred. The accuracy of age estimation is decreased postnatally as the age advances due to the external factors that affects growth, which consequently leads to individual as well as sex variation in stature, especially during the adolescent growth spurt. The juvenile skeleton's age can also be estimated from the developmental state of primary and secondary center of ossification. The ossification in the embryonic and fetal stage initiates from the skull, vertebrae, and primary centers of long bones and their girdles. The ossification centers starts in the embryonic centers with a nondescript spherical or in the form of ovoid nodules of bones, which remains unidentifiable in isolation and in skeletonized remains. Now I'll be talking about age estimation in young adult stage. In the young adulthood stage, the estimation of age at death has much relevance as many areas of the skeleton remains incomplete till the second and third decades of life. This stage begins from the termination of height, which is marked by the fusion of all the long bones till the time complete fusion of all the other epiphyses has reached. These include the regular jugular growth plate of the skull and postcranially the sacral vertebral bodies, the iliac and ischial epiphyses, the ring epiphyses of vertebral bodies, the epiphyses of the scapula, costal notches of the sternum, and the medial epiphyses of the clavicle. In the adult stage, the process of aging utilizes majorly three areas of the skeleton, that is, the fusion of cranial sutures, morphological changes in the pubic symphysis, sacroiliac joint, and ventral aspect of the ribs. The epiphyseal morphology of the ventral demi-face of the pubic symphysis undergo through an extended period of age-related changes up to 35 to 40 years. With the use of component phase analysis, this has been put to use for the estimation of age with each range stating its own unique morphology. As a part of a multifactorial method, the change in the sacroiliac have been used for the purpose of estimating age at death, but it was drawn out that the age ranges were too large for the application in forensics. The visible signs of degenerative disease of the joint as marked by the lipping of vertebral bodies and osteophytes surrounding other joints and muscle attachments, it appears only after 40 years of age. The later decades of life are difficult to put to estimation with any degree of accuracy because these features are quite variable and are dependent on factors like genetics, nutrition, and lifestyle. With advancing years, the sclerotic fusion of menobriosternal joint increases in case of the females. The primary cartilaginous joints between the manubrium and the costal cartilages of the first ribs may also synostose in older individuals but have never been reported in an individual where prior menobriosternal fusion has occurred. Estimation of age at death is provided effectively as the continuous remodeling of the bones take place throughout the adult life. Now, we will discuss the approximation of stature. The approximation of stature from the skeleton of an individual can be simply obtained by calculating the stature by measuring the relative proportion of different parts of the body, both in relation to each other and in relation to the overall height of the individual. The stature can be estimated with greater accuracy when the long bones of disarticulated adult skeleton is available. The greatest accuracy will be obtained when undamaged bones of unknown sex and ethnic identity are utilized, as the height of the individual is both sex and race dependent. Now, I will tell you how ethnic identity is ascertained. The determination of race or ethnic origin is the most difficult and unreliable attribute that the forensic osteologist must attempt to establish. The differences between the various races of men are small, and the consequent variation exhibited in the skeleton is difficult to assess with any degree of accuracy. It follows as the most obvious ethnic difference in the living are either displayed in the face or the integumentary system. So, the skull is the most studied skeletal element in this regard. Although the history of anthropology is littered with explorers who have returned home with the skulls of many tribes to study, and much of the earlier work concentrated on various rather than on discrimination. Recently, two computer-based multivariate approaches have been developed on large database samples with the specific purpose of analyzing ancestry and therefore ethnic origin. Ethnic identity from the limb bones utilizes variation in the intermembral indices. For the upper limb, the brachial index is computed as radial length multiplied by 100 divided by humeral length, and for the lower limb, the crucial index is the tibial length multiplied by 100 divided by femoral length. Both artificial dental work and innate dental traits can be useful for assigning ethnicity. Now, I'll be discussing about positive identification of personal identity. Once biological identity has been established, the forensic osteologist must attempt to personalize the information available so that the identity is achieved. During the Asian tsunami, the three principal means of personal identity were achieved through dental records, fingerprints, and DNA analysis. All of these require a pre-existing antemortem dataset be available for comparison. When it is known that a person is missing or deceased, then these records, should they exist, are passed to the existing authority. However, when an unidentified set of remains are found, then dental records are of no value until a possible identity is achieved. Under these circumstances, the forensic osteologist must look to other possible evidence within the remains that may assist with the identification process. Identification of a pre-existing medical condition or the presence of surgical hardware may prove of value in establishing a productive line of inquiry. Equally, the forensic osteologist has a prominent role to play in the identification and reconstruction of trauma to the skeleton. This may heal trauma that has occurred some considerable time before death or damage that could indicate the likely cause of death. Imaging techniques such as facial reconstruction, facial superimposition, or facial art can be attempted with varying level of success. These are specialized areas that lie outside the capabilities of most forensic osteologists, and therefore it is essential that a good working relationship is developed between discipline specific experts. The forensic osteologist may feel pressured by investigating authorities anxious to solve a case to make a positive identification of an individual. It is essential to be absolutely sure that the remains are those of the missing person and the identification process rests on secure and verifiable evidence. The consequences could mean the end of distressing uncertainty and eventual closure for the family of a deceased individual with the acceptance of death and beginning process of grieving. In the case of a possible crime, it could also mean the arrangement and trial of a suspect. Throughout the forensic examination of skeletal remains, there are various legal and sometimes political issues and procedures such as confidentiality and continuity of evidence that must be carefully followed. These usually follow cooperation with other personnel such as forensic pathologist, archaeologist, odontologist, and forensic examiners. The value of interdisciplinary discussion and consultation cannot be overemphasized, and the forensic anthropologist must work as a part of an active team rather than an isolated adjunct. Now, I will tell you some interesting and notable facts. Skeletons are good age markers because teeth and bones mature at fairly predictable rates. For toddlers to teenagers up to 21 years, teeth are the most accurate age indicators. Some of the best indicators of adult age are in the pelvis. The clavicle, which is the collarbone, is the last bone to complete growth at about 25 years. Measuring the length of long bones can give an estimate of age for children, but this technique is useful only until the bones have stopped growing. The tibia completes growth at about 16 years or 17 years in girls and 18 or 19 in boys. For toddler to teenagers up to 21 years, teeth is the most accurate age indicator. The eye and nose opening in the skull and certain proportion of the skull vary by racial group between the Mongoloid, Negroid and Caucasoid races. By examining the skull or certain part of the skulls, forensic folks can determine the race. The most standard forensic text contain regression equation from which adult male and female structure can be calculated and resources to there is recommended. These formulae that uses femur and tibia have the lowest standard error of the estimate as these bones form an integral part of the individual's height. When the preferred skeletal remains are not available, an attempt in stature estimation may be made from a metacarpal, metatarsal, clavicle or even fragmentary long bones, but accuracy will decline rapidly with the use of incomplete bones. So students, now let us summarize the module. When skeletal remains are discovered, it is the duty of the investigator to identify the decomposed or fragmented bones. Thus, the investigator begins his search with the answers to the questions which include: are the remains actually bones? Are the remains of human? It may be difficult to completely identify the fragmented bones, but in the hands of a skilled and experienced investigator, the investigation becomes easy. The other questions which pops into the mind of a forensic anthropologist are: is it a single bone, or is it commingling of one or two bodies? What sexes are the bones? What is the age of the person? What is the height or stature of the person? What is the race or ethnic origin? And can we identify personal identity from the remains? Thus, it reflects that the forensic anthropologist must work as part of an active team rather than an isolated adjunct. Thank you.